So today we're going to be working on converting equations to standard form. And what does standard form mean? Well, that means that both the x and the y variables are on the left side, canceling out any fractions and or decimals. Now, an additional aspect of standard form is typically that the x and the y variables are considered positive, or that it's an ax plus by, meaning we may need to manipulate the y's. We're going to kind of ignore that aspect because I consider it a little redundant, but we'll see why here in just a moment. So let's take a look at our starting equation. Remember, we want the x and the y both on the left-hand side and no fractions or decimals. Now, many of you might be able to move the fraction over first, but I think one of the most important things is let's cancel out the fractions or decimals in the beginning because that allows us to work with whole numbers, which in my opinion is a little easier to work with than the fractions. Not that fractions are difficult per se, it's just that it might prevent some casual mistakes or some common errors. So let's go ahead and let's take our equation right here, and I'm going to put brackets around it because we're going to be canceling out one of these two fractions. Now, I'm going to go ahead and I'm going to start with the 2, which means I'm going to multiply everything in the equation by 2, so that way this disappears. What that means is that times 2 divided by 2 cancels out, and I'm left with just, actually I'm going to write this in blue to show that this has remained the same, my 1y. Everything else gets multiplied by 2, so this 1/3 becomes 2/3. This 2 becomes 4. There we go. And so again, the same thing happens when I want to cancel out the next fraction. So what I'm going to do is I'm going to do the exact same thing. I'm going to find one of these, and I'm going to multiply everything by 3. Now, what's really cool is that this cancels out because I'm multiplying times 3 divided by 3, which leaves me with a negative 2x. Everything else gets multiplied by the full power of 3. So 12 equals 3y. And so you can see in 2 steps, cancel out the 2, cancel out the 3. Now I've got this equation. Now with this equation right here, it allows me to simply move that x over. So I'm going to add a 2x to both sides, which is going to cancel this out. And then I'm going to list my 2x plus 3y is equal to 12. And there is my equation in standard form. Awesome. Think we got it? Well, let's try one more. Let's go ahead and let's get started on this one. So this one's a little more straightforward. What I'm going to do is I'm going to bracket up my equation, and I'm going to get rid of the 5. Now, in this case, both of them are 5, which means both of them get canceled out. So I'm left with a 2x right here and a negative 2x right there. Everything else gets multiplied by 5. So the y gets multiplied by 5, so it's plus 5y. And the 4 gets multiplied by 5, so plus 20. And so then I just move all my x's and all my y's over to the left, which means I'm going to add 2x. It's going to cancel that out over here. And I'm going to have 4x plus 5y is equal to 20. And there's my equation in standard form. Perfect. Now you might hear in the background some music. That's because the band has decided to practice during this time, so you're going to hear them quite often in these videos. I hope that it is delightful and adds to the ambiance of math. So while listening to this delightful math, I want you to go ahead and I want you to try number 5. So pause the video, try number 5, unpause it when you're done to see how you did. Delightful might not be the right word right now because it sounds like they're warming up. Okay, well, let's go ahead and knock this out. So just like before, I noticed that I only have one fraction, and that fraction is going to be a 2, and they both have a 2. So when I go ahead and multiply everything by 2, I know I'm going to cancel out to a 1x and a 1y, but it's not going to cancel out over here, which means that becomes 2y, and that becomes 10. The last thing I'm going to do is move my 2y over, so minus 2y. It's going to cancel that out over here. And I'll have a 1x minus 1y is equal to 10. Now, here is, in my opinion, what standard form looks like. I have a constant in front of the x, I have a constant in front of the y that are non-fractions, non-decimals. I have a non-fraction, non-decimal as my c term, or my whole constant. Now, technically, according to standard form, what it wants us to do is it wants us to separate this into the ax, which would be 1x, plus by, and my b is going to be a negative 1y. So that way I have an ax plus by is equal to c, which is 10. I think this is a little redundant. I think 1x minus 1y is equal to 10 is good enough. You make the choice on whatever you best see fit. So we're going to try two more, and they're going to be a little different. For the first one, we have parentheses. In the second one, we just have several terms. So let's go ahead, pause the video, try out these problems, and when you're done, resume it and see how you did. Okay, so let's see how we're doing here. So with this one, there's no fractions to get rid of. All I need to do is I can distribute. So I know that my negative 2 times x is going to give me a negative 2x. I know that my negative 2 times my y is negative 4y. I don't know why I did that in blue. Let's go back and kind of equals. Okay. And then over here, I also have a set of parentheses, which means I distribute, or I multiply more than once. So I get 3y plus 6. There we go. And the last thing that I'm going to do is I'm going to go ahead and I'm going to move that 3y over, minus 3y. It's going to cancel that out over here. And I'm left with a negative 2x minus 7y is equal to 6. Now again, I consider this good enough. We have a whole number, or I guess I should say an integer in front of the x, I have an integer in front of the y, and I have an integer as my constant. Now, technically speaking, we said that we wanted these both to be positive. We saw the little trick with this one, but what happens if that one is not positive? Well, basically what we do is we would multiply everything by negative 1, and it would change that out. Now, if I multiplied everything by negative 1, that would leave me with a positive 2x, a positive 7y, and a negative 6. Again, I don't necessarily see the discrepancy between the two, but depending on which course you're in, use your best judgment. And then for the second one, we notice that, hey, we have fractions again. So I'm going to take my brackets and I'm going to multiply everything by a 3, which means that and that cancel out. So I have a 5y right here and a 10y right here, which cancel themselves out. Everything else, I got a triple. So that 5 becomes a 15, that 2 becomes a 6, and that single x becomes a 3x. Boom. And there we go. And so then in this case, I move my 10y, which is going to cancel that out. I'll have a 3x minus 5y is 6x plus 15. And then I'm going to go ahead and move my x over. So minus 6x, which is going to cancel that out. So I'll have negative 3x minus 5y equals 15. There's my answer. Or like I said, if you wanted to go ahead and multiply it by the negative 1, you could get yourself a 3x plus 5y is equal to negative 15. Either one of those are acceptable. And there you go. So today we're going to be graphing standard form. Now, in previous videos, what we've done is we've converted equations to standard form, and the reason why is because standard form is very easy to graph on an x and y axis without having to worry about what is the slope, what is my scale up and down. It gives us two concrete points on each axis, and we can connect the two. The only thing we need to find is the x-intercept, where it crosses my x-axis. We plug in a y of 0 because there is no height on the x-axis. Then we'll find the y-intercept by plugging in x of 0 because there is no movement to the left or right on the actual axis. So let's see what that looks like in motion. So for my x-intercept, what I'm going to do is I'm going to plug in a value of y is equal to 0. Remember, when it crosses this axis, there's no height. So I rewrite the equation with a 2x plus 3 times 0 equals 12. And now the cool part about this is that any number times 0 cancels out. So really all I'm looking at is 2x equals 12. And that's solved as simply as dividing by 2, which means that my x is equal to 6. And I can do the same thing with my y. I can say, okay, to find my y-intercept, I'm going to plug in a value of x is equal to 0. Because remember, when we cross this line, there's no movement to the left or right. It's on the line. So I rewrite the equation as 2 plus 3y equals 12. And I plug in a value of 2 for my x. And again, the cool thing about this is that those cancel out. I'm really only dealing with a 3y equals 12, which is solved as simply as dividing by 3, which means that my y is equal to 4. Now, the 2 points that I have to graph an x of 6. I don't have enough space, so instead of counting by 1, 2, 3, 4, 5, I'm going to count each of these by 2's. So I'm going to get 2, 4, 6. I get my intercept right there. I go up by 4. 1, 2, 3, 4. Yep, so my y's can be by 1's, or my x is by 2's. And then basically what I do is I connect these two with a straight line, draw arrows on each end to show continuity, and I label either by this arrow or by this arrow 2x plus 3y is equal to 12. And that's it. So let's try one more just to make sure we got this down. We have two intercepts we need to graph. We have an x-intercept and we have a y-intercept. Now, to find the x-intercept where it crosses this, I'll plug in a 0 height, so y is 0. To find the y-intercept, I plug in a 0 width, or x is equal to 0. So my two equations, I literally copy this equation twice, once with a 0 for y and once with a 0 for x. So 4x plus 5 equals 20, and then 4 plus 5y is 20. Remember, once with a 0 for y and once with a 0 for x. And I solve it twice. The cool part about both these is I can ignore the 0 term. And I'm just dealing with a 4x equals 20, so divide by 4, and I get x is equal to 5. I'm really dealing with 5y equals 20, so divide by 5, and y is equal to 4. So the 2 points that I graph, let's see, that's 1, 2, 3, 4, 5. It fits. And then 1, 2, 3, 4. It fits. So I'm going to connect these 2 points with a line. And I'm going to label it either at the top arrow or at the bottom arrow because I have more space up here. 4x plus 5y is equal to 20. And then one of the things you might want to do is you might want to label these 2 points. Again, these are important points for later on in later sections. So I'm going to go ahead and label 0, 4 and 5, 0. Boom. We have our line. As easy as 1, 2, boop. Okay. So what happens if instead of having all positives, I happen to have a negative? Well, nothing really changes here. I'm still going to have an x-intercept where I plug in a value. I'm still going to have a y-intercept where I plug in a value. Again, those values are still the same. When I want to find my x, I plug in a 0 height. When I want to find my y-intercept, I plug in a 0 width. I'm going to rewrite my equation twice. So 2x minus 5 equals 40. And then 2 blank minus 5y is 40. I'm still going to plug in my 0 for y and my 0 for x. And I'm still going to ignore the 2 terms because they 0 out. I get a 2x equals 40, divide by 2, and I get an x is equal to 20. Down here, I'm going to divide by a negative 5. So the only thing I need to pay attention to is a positive divided by a negative is going to give me a negative 8. Okay. Now, both of these I'm actually going to have to scale because I can't actually go out 1, 2, 3, 4, 5. The 20 is going to be somewhere over here. So I'm going to have to count by something more than ones. So let's see. How about if I count by 5s? So 5, 10, 15, 20. Awesome. So 20, 0. So I'm counting that by, what do we say, 5s? This is negative 8, so 1, 2, 3, 4, 5. Again, I'm dealing with something that's below my graph, so I'm going to count by something more than ones. So how about by 2s? So 2, 4, 6, 8. Perfect. So 0, negative 8. I'm going to connect those two with a straight line. Draw arrows on my end for continuity, and I'm going to label one side or the other. So 2x minus 5y is 40. Boom. There we go. And so what I want you to try is I want you to try this last one. Go ahead and pause the video, try out the question, unpause it when you're done, and see how you did. Okay, so let's see how we're doing. So I'm going to plug in a number for my x-intercept and a number for my y-intercept. For my x-intercept, I'm going to plug in a 0 height, and for my y-intercept, I'm going to plug in a 0 width. So negative 3x minus 7 equals 63. Negative 3 minus 7y equals 63. Again, when I plug in my 0 for my y, and I plug in my 0 for my x, I'm going to promptly ignore the terms because they zero out. Negative 3x equals 63, so divide by negative 3. Let's see, that's x equals, almost forgot my negative sign. 3 fits into 6 twice, 3 fits into 3 once. So I get a negative 21. For my y-intercept, I'm going to divide by negative 7. So I'm going to get a y equals negative 9. Perfect. So it looks like 1, 2, 3, 4, 5. I can't fit 21 on there, so I'm going to count by 5s again. So 5, 10, 15, 20, 25. It's going to be roughly right there. So negative 21, comma, 0. 1, 2, 3, 4, 5. I can't count by 1s on my y's, so I'm going to count by 2s right here. So 2, 4, 6, 8, 10. It's going to be somewhere between the two at 0, comma, negative 9. I'm going to connect those 2 points with a straight line, draw arrows for continuity, and label it. Boom. How'd you do? So today what we're going to be doing is we're going to be graphing in standard form. Now, like we've done in other videos, standard form we're going to be plugging in 2 intercepts. So I'm going to plug in my x-intercept by getting a y equals 0 and plugging in my y-intercept by using an x equals 0. And unlike prior videos, none of these are going to be nice even numbers. We're going to get a lot of fractions today, just to be sure that we know how to graph this stuff. So let's go ahead and let's get started. To graph my x-intercept, I know that I'm going to be plugging in a y of 0, which means I'm going to say, okay, so 2x plus 3 times 0 equals 7. And what I know is going to happen is that's going to cancel out, because 3 times 0 is 0, so I have 2x equals 7. I'm going to divide both sides by 2. And what I'm going to get, see, that's step 1, step 2. I have an x equals 7 halves. And then likewise, to find my y-intercept, I'm going to plug in x equals 0. So 2 times plus 3y equals 7. I'm going to plug in a y, or an x of 0 to find my y-intercept, which I know this is going to cancel out. I'm going to say 3y divided by 3 on each side. Kind of blended those 2 steps together because I'm running out of space. So I'm going to get a y is equal to 7/3. Awesome. So in this case, I know 7/3 is going to be just over 2 because I know 3 fits into 7 twice, or 6, but not quite 3 times. So I'm going to go somewhere above 2, but not quite 3. Actually, I'm going to do this in, kind of too late for that point, but I'm going to do this in green. So it kind of sticks out. And for this one, 7 halves, well, 2 fits into 7, 6, so that would be 3 times, but not quite 4 because that would be 8. So 1, 2, 3, but not quite 4. Now that I've got those 2 points, I'm going to go ahead and I'm going to connect them with a straight line. There we go. And technically what I want to do is I want to label my 2 points. I'd say, okay, so this is 7 halves, comma 0, and this is 0, comma 7/3. Boom. There we go. So let's try that one more time. Now I know that we have to plug in an x-intercept, which means my y value can't have any height when I'm looking at the ground. So 4x plus 5 times 0. I know this is going to cancel out, and I'm going to divide both sides by 4, which leaves me with x is 11/4. So I know 11/4, 4 fits into 11 twice for 8, but not quite 3 times, otherwise it'd be 12. So at twice, so 1, 2, but not quite 3, right there. Secondly, for my y-intercept, where it crosses the wall, I can't have any width, so a 0 for x. Plug in a 0 for my x value. Let's see, that's going to cancel out. I'm going to divide both sides by 5, which is going to leave me with a y is 11/5. Now with this, 5 fits into 11 twice for 10, but not quite 3 times. So somewhere between 2, but not quite 3. I have those 2 points. And so then I'm going to go ahead and connect them with a straight line. Perfect. Label my 2 values at 11/4, comma 0. And that point is 0, comma 11/5. Perfect. So I want you to try this one. Go ahead and pause the video, give this one a shot, and see how well you did. Okay. So depending on how well you did, I know that I have an x-intercept, which means when I'm finding the ground intercept, I know I have to have a 0 height. And I know later on, for my y-intercept, I'm going to have to plug in a 0 width, which means x is going to be 0. So 2x minus 5. I'm plugging in a 0 for the second variable. And down here, I'm plugging in a 0 for the first variable. Perfect. So I plugged in a 0 for this one, and then a 0 for the other one. That's going to cancel out, and I'm going to divide both sides by 2, which is going to leave me with an x is equal to 3. Ooh, a whole number. Down here, I'm going to divide both sides by -5, which is going to leave me with a y is equal to -6/5. So for my x value, 1, 2, 3. For my y value, it's negative, so 5 fits into 6 once, but not quite twice. So there we go. Pop my straight line through there. I'm going to label my points. So that's going to be 3, comma 0. This point is going to be 0, comma -6/5. Perfect. And so we're going to do one more just to make sure we got that point down. So go ahead. This is the last one. We have 2 negatives out front, so go ahead and pause the video and see if you can't knock this one out. Okay. So I now need to find my 2 intercepts, which means an x-intercept, which would be a y of 0, and a y-intercept, which would be an x of 0. So -3x minus 7 times my 0. This would be a -3 times my 0 minus 7y. Perfect. These are going to cancel out, and I'm going to divide by -3, which is going to leave me with x equals -3. Down here, I'm going to divide by -7, which is going to leave me with a y is -9/7. So -3, 1, 2, 3, -9/7. So 7 fits into 9 once, but not quite twice. So I've got that right there. Boop. Kind of drew my line really big there, but that's okay. Label my points. 0, comma -9/7, and then -3, comma 0. And there we go.